suggested new model of atom called Thomson atomic model. Thomson atomic model depend on the Thomson cathode ray tube experiment that he made, and different scientists made it with them. Okay, this is the fourth one that we mentioned. Okay, let's go to another scientist. Okay, we have here the biggest one that we make some interesting with it. We have here Rutherford. Okay, Ernest Rutherford. What is contribution? It's from 1871 till 1937. What is the contribution of Rutherford? It's a very important and very interesting at the same time. Okay, we will have also here video for this one. You can see it at the end. Okay, I will leave its URL for you at below the video. Okay, what is the beginning of Rutherford? Okay, the first one that put the atomic model of depending on the facts. Depending on what? Experimental facts. Okay, all of things that before not depending on facts, but now beginning from Rutherford, it depend on what? It depend on experimental facts. Okay, okay. Rutherford has students that make researches with him, Geiger and Martin. Okay, so they make the apparatus that can discover what his behavior. Okay, we have the experiment, or we can depend on gold foil experiment. We called it gold foil experiment. It show the mass of atom was concentrated in the nucleus. So the main part of the atom that be present inside what? Inside the nucleus. And we called it nuclear model of the atom. Okay, remember well, I say we have shape for each scientist, shape for the atom of each scientist, and name for it. Okay, to mention what is the name of the behavior or the discovering of this scientist. Okay, we have here the nuclear model of atom. So he discovered or mentioned all the component of the atom, but concentrated on some of them at the end. Okay, another one here we have, he make theories about the neutrons, not discovered by James Chadwick, but he put some behaviors or some thinking about what? About neutrons. Okay, not all of them belong to James Chadwick. Okay, we must mention all the history, and you will discover that we have some scientists that we didn't say anything about them. Okay, as they neglect some behavior or some contribute of it in discovering the atom. Okay, we have here fact that Ernest scientist was Thomson student. So after Thomson, after Thomson here we have Rutherford has its contributing, who disproved Thomson blood budding model. Okay, refused all discovered. Okay, although Ernest Rutherford is or was, as we talking about the past, Thomson student, disproved the Thomson blood budding model. Okay, he refused all things that what that Thomson say about the atom. Okay, and it's a shock for us that we are going to illustrate what happened in Rutherford nuclear model of the atom. Okay, here we have Rutherford gold foil experiment. What we can say or what we can conclude from this drawing. Okay, we have here a radioactive source that evolve a kind of particles or a beam of alpha particles. If we want to measure the properties of these particles, we must put it in a box and hole that contain these beams of alpha particles. And in the structure here we have gold foil, and we will know that gold adds all make properties, or that we can make different activities depending on the gold atom, as it helpful in making activities. Okay, another one here we have the defense here, or a sheet surrounding it from zinc sulfide. Here we have a sheet of what surrounded it of zinc sulfide. Okay, what is the observation here? We have third observation, and we must concentrate on each word here. The first one, most alpha particle here travel through the foil undeflected, or travels in straight line. This is the first one. We can say the word most. So atom, okay, if you have a whole street, nobody in travel in the street, so you can move fast. It depend on the empty of this street. So the atom is mostly empty space. This is the first one. So if we have the word most alpha particles, depending on what? Depending on the atom most vast in the space, or empty space. Another one, some alpha particle. We have here some, the word some, and here we have deflected or away small amount of what? Some alpha particles away from its straight line. So it can't move here in the same way, as it what? It block in front of something that make it move away. So here we have the nucleus contains charge that same to me. I make a repulsion for you, or go away from you, or make deflection. So here we have nucleus contains something inside it that has a positively charged particles, and it's some, not a lot of amount or large area of the atom. Okay, the last one here, essentially and alpha particles travel back from the foil, or returning back when they hit the gold foil, return back again. Okay, so most of the here nucleus contain the atom mass. It's a very heavy particle that I can't move anyway in front of the gold foil. So we have here three interpretations that illustrate what? Illustrate the activity or experiment. Some means that there is space, and most here means that empty space. The second one, some alpha particles, means that there is a positive charge here. We called it the nucleus at the end, and they make reflected back here. We have a lot, we have no, we have very small amount or little amount of alpha particles return back. So the nucleus here contain most, or carry most of the atom mass. So we can make this one. And note very well that here we have all you need to understand about alpha particles at this point, is that they are what? They are the same charge as alpha particles. So as the nucleus. So here we have alpha particles means that they are positively charged, as they make deflection or go away from the what? From the nucleus of the atom. So we have here the main property of alpha particles that we mentioned, that they are positively charged particles. Okay, we have the gold nucleus here, and we can see the atom in front of you. We have the gold nucleus, and we have the source of it. We will see the video also, that make Rutherford gold foil, and it will move. Some of them move straight, some of them make deviation, and some of them, or little amount of it in front of alpha particles, make what? Make deviation. Okay, make returning back little amount of it. So we can mention each one of the alpha particles or the amount of it and its behavior. Okay, that's all about what? That's all about Rutherford. Okay, we have here the scientist that we mentioned it before a lot. I think it's one of the most important one that we make spot on it a lot. We have here Nel Bohr. Nel Bohr, it's period from 1885 till 1962. What is the contribution of Nel Bohr here? We have, okay, the first one we called its structure, or it make what we called atomic model or electron shell model. Okay, it make electron shell model, as we mentioned in previous years, that it discovers the main energy levels of the atom, the seven main energy level that take the letters K, L, M, N, O, P, Q. Okay, so its structure here, or its contribution here, from starting as we have electron shell model. So we have here a lot of names for each one and its discovering or its model. Okay, he suggested that electron of an atom can revolve around the nucleus only in a certain distance, or a certain discrete here, or separate parts, or separate orbits, or shell. This is the discovery of what? Of Bohr. This is the shape here. Okay, we have here, this is what? This is the third shape or fourth shape for the models that we discussed before. Okay, we said Democritus, we said what? We said John Dalton, we said Rutherford, we said Thomson, and here we have Nel Bohr. It is the main important function here, that discovering what? Discovering the quantum model. It means that all electrons that present in each shell that take a quantity of energy or amount here that can be present in this part of the atom. Okay, we have here the contribution of what? Of Schrödinger, Erwin Schrödinger. Erwin Schrödinger makes some contribution here. What is his contribution? From 1887 till 1961. What is contribution? He make a, or discover, or make a wave function, or it come from the physics part of science that make a mathematical model for distribution of electrons in an atom, or we call it electron cloud model. So we have here only the name of the model that Schrödinger made it. Okay, we have here the contribution in discovering the electron, the name of the model, electron cloud model, and he mentioned that depending on the mathematical model, that electron that has a wave particles as can move in space without any doesn't need any matter to move, and it can also have a high speed and all properties that belong to it, like the light. Okay, probability of it, where electrons are three-dimensional model, better describes three-dimensional space. So if we mention that electron can move according to x dimension and y dimension and z dimension, only Bohr before it here, okay, this is after Bohr, that mentioned that only we have one dimension or one dimensional particle or one dimensional behavior, and also Schrodinger depend on the mathematical model that wave